All right, Algebra 2 students. Today we are going to work with complex fractions. This is 9.3 and it's actually day 2. We already spent a day on 9.3 where we added and subtracted. So day 1, adding and subtracting. And what were we adding and subtracting? Well, that's where we were adding and subtracting rational expressions. An expression has no equal sign. Has no equal sign. Thus, it cannot be solved. It can only be simplified. We are going to work with rational expressions again today, but now we're going to be working with complex fractions. Because they are rational expressions, we cannot solve them. We can simply simplify them. Now would be a great time in the video to pause, okay, get a chance to write down the definition of a complex fraction. That is the entire definition right there. Pause the video, read this thing through, okay? This is the method down here on how to simplify the complex fraction. All right, now that you've had a chance to read what a complex fraction is, see the method, or write down the method, now we are going to try to actually do a problem. I have a problem up here on the board. You should pause this video right now and write it down. All right, now that you've gotten this thing written down, my first goal, okay, the very first thing that I want to do is I want to find the LCD of all the fractions. So, if I'm doing an LCD of all the fractions, I'm thinking to myself that this thing right here is one fraction, then I have this one, and finally this one here, okay? And as I'm going through the LCD, I'm asking myself, what is missing? If I'm thinking about what's missing, if I look at my very first, my yellow one right there is an x plus 4. If I look down at green, oh, x plus 4 is there. It's not missing anything. The yellow is not missing anything that the green has. But the yellow is missing the x. So, this would need an x. Well, okay, let's think this thing through. What's missing? Okay, from the top, I would need an x. Then this green one is missing an x. And the blue one would be missing an x plus 4. Thus making the LCD x times x plus 4. LCD is x times x plus 4. I take this LCD right here, and I am going to multiply it by my entire top and entire bottom. I am taking this whole big complex fraction here, and I'm multiplying x times x plus 4 on the top, and x times x plus 4 on the bottom. So when I'm multiplying now, I'm taking this, and I'm bringing it in times this stuff. I'm taking this and times both of these. So let's see if I can't duplicate this real quick. Now, you see down at the bottom, or I should start at the top here. You see that I have x times x plus 4 times the top there. So that means this x, this very top now, is being multiplied by x times x plus 4. Inside the bottom now, I'm also doing x times x plus 4 and x times x plus 4. Once I've done that, I need to look at it, stare at it as long as I have to, before I notice, oh, this x plus 4 on the top fraction will cancel with this one. What's left there? Well, let's put a little arrow over here. On the top I have 5 then times x, so I'll put 5 times x. There's no more bottom. Okay, and then I carry my big division line over. Okay, on the bottom I have x plus 4, that's 1 times x down here, plus sign. Oh, this x will go with this one, and I have 2 times x plus 4. Now I just need to simplify. Well, it looks like on the top I got 5x. So I'm going from here over here. 5x divided by x plus 2x plus 8. Which then becomes 5x over 3x plus 8. And of course, the top can't factor, the bottom can't factor, so this is going to have to be minus. That would be a great time in the video. Pause it. Okay, pause the video, write it down again maybe, and work through that problem. We only have one more example. This is the last example that I'm going to do with you today, and then we're going to work on the homework. Okay, so I got this complex fraction. I need my LCD. My LCD, if I can try it in the correct order here. LCD, okay, what's in the bottom? Well, I'd have x minus 5, oh, and then just an x. And then an x, okay. So x times x minus 5. That means I need to take x times x minus 5 and times every single fraction. That's a little sloppy. Let's make this one bigger. This is x times x minus 5. Okay. All right. After I've done that, stare at it again until you see it, but I have x minus 5, x minus 5. If I've done this right, I should get all this stuff to go away. X, 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 x minus 5, x minus 5. Now it's just a matter of writing down what's left. On the top, it looks like I got 6 times x plus 1 times x minus 5. Then on the bottom, it looks like I have 3 times x minus 5 minus, this is plus a negative 2 times x. All right, if I work this thing out, I think the top becomes what? 6x plus x minus 5 divided by 3x minus 15 minus 2x, which would be 7x minus 5 all over x minus 3. The top doesn't factor, the bottom doesn't factor. This is my final answer. And that completes the notes for 9.3. This is, again, 9.3, day 2. If you need extra examples, please check my notes posted online. Also, feel free to visit khanacademy.org and search complex fractions. There are a lot of good videos on that.